In this video, we'll be going through question 11 from the 2024 HSC Mathematics Extension 2 exam. Part A. Find the integral of x e to the x dx. So here we're starting off the short answer response with a very standard question, integration by parts. I have to choose something to be my u and something to be my v dash. Now I'm going to choose x to be my u because when I differentiate it, it becomes 1 and it essentially disappears. My v dash is going to be e to the x, and so my v will be e to the x as well. So now we just apply the integration by parts formula, u times v minus the integral of u dash times v, 1 times e to the x, which is e to the x. And then integrating e to the x gives us e to the x, and we have a plus c because it's an indefinite integral. Okay, part B. Let z be equal to 2 plus 3i and w equal to 1 minus 5i. We want to find z plus w bar. So z plus w bar is going to be 2 plus 3i plus 1 minus 5i bar. So that's 2 plus 3i plus 1 plus 5i. So that's 3 plus 8i. Part 2 is to find z squared. So z squared equals 2 plus 3i all squared. This will be 4 plus 2 times 2 times 3i, which is 12i, plus 9i squared, which is minus 9. And so we have minus 5 plus 12i for z squared. That's the end of part B. Part C. Find the angle between the two vectors u, which is 1, 2, negative 2, and v, 4, negative 4, 7, giving your answer in radians correct to 1 decimal place. Okay, so when I want to find the angle between two vectors, I'm going to appeal to the dot product, because the dot product, u dot v, is equal to the length of u times the length of v times cos theta. So I'm involving the angle between the two. So I can make cos theta the subject, and I get u dot v divided by the length of u, the length of v. Okay, so what is u dot v? U dot v is going to be 4 minus 8 minus 14 divided by the length of u. Now the length of u will be the square root of 1 squared plus 2 squared plus negative 2 all squared. And the length of v will be 4 squared plus negative 4 squared plus 7 squared. Okay, let's extend out that fraction. All right, what's my numerator here? I have negative 4 minus 14, that's minus 18. My denominator, well, this is going to be, if I can get my laser, this here is going to be the square root of 9, which is 3. And this here is going to end up being the square root of 85. So that's cos theta. Taking arc cos, the inverse cos of both sides, will give us some value, and we want it to be in radians and correct to 1 decimal place. So we'll get 2.279 ... and then to 1 decimal place is 2.3. Okay, and that's our value of theta. Part D. Evaluate the integral from 0 to pi on 2 of 1 over sine theta plus 1 d theta. Okay, so this is a question where it looks very likely that we're going to appeal to the t results. So we'll say let t equal tan theta on 2. And now we need to differentiate. So dt on d theta is equal to 1 on 2 sec squared theta on 2. Now sec squared I can write as 1 plus tan squared, but tan is equal to t. So this is equal to 1 on 2, 1 plus t squared. And I'm going to make d theta the subject. And doing that gives me 2 dt rather on 1 plus t squared. So there I've got my result to sub in for d theta. Now I also need to change my bounds. So when theta is equal to 0, t will be equal to tan 0, which is 0. And when theta is equal to pi on 2, t will be tan of pi on 4, which is 1. So this is equal to the integral. I'm now going from 0 to 1. 1 divided by sine theta. I'll now replace that with its t result, which is 2t on 1 plus t squared plus 1 times d theta, which I can now replace with this. So that's going to be 2 on 1 plus t squared dt. Okay, and we are multiplying those. So I'm going to multiply that denominator by the 1 plus t squared, and let's see what we get. We end up with the integral from 0 to 1. On the top I have a 2. In the bottom I have 2t plus 1 plus t squared dt. And that's quite convenient because in the denominator I have a perfect square. That'll be simply t plus 1 all squared in the denominator. Now I can bring that up into the numerator and integrate that quite nicely. That'll be 2 into t plus 1 to the negative 2 dt. And now I simply add 1 to the power and divide by the power. So it'll be 2 times t plus 1 to the negative 1 divided by negative 1, and also divided by the inside derivative, which just happens to be 1, which is nice for us. And I sub in 1 and 0. Before I sub in, I might just tidy things up a little bit for myself. Looks like I've got negative 2 on t plus 1. And now I'll sub in. So when I sub in 1, I get minus 2 on 2. And when I sub in 0, I get minus 2 on 1. So that's 2 minus 1. Sorry, that's negative 1 plus 2, I should say. Yeah, which is 2 minus 1. And that should be equal to 1. All right, and that's the final answer for part D. Part E. Write the number root 3 plus I in modulus argument form. Okay, root 3 plus I. Now, if you've done enough practice, you should probably be able to actually just quote this because it pops up so often. But whenever I want to convert from a Cartesian form to a mod arg form, I always do a quick sketch of where the complex number is, just to see what quadrant I'm living in. So I go across 3 units and up 1 unit, so roughly like that. So I know I'm in the first quadrant, that's good. That helps me to determine work out how to determine what my argument is. And in this case, it's going to be inverse tan of the imaginary on the real, which is pi on 6. So my argument is pi on 6. My modulus is going to come from root 3 squared plus 1 squared, and then we're square rooting that, which is 2. So 2 cos pi on 6 plus I sine pi on 6. I would say to avoid using cis notation, since it's not really something that's in the syllabus, write it as cos plus I sine. Anyway, that's an easy 2 marks. Now the next part says, hence or otherwise, write root 3 plus I to the 7 in exact Cartesian form. So I want to raise this number, root 3 plus I, to the power 7. So that's the same as raising 2 cos pi on 6 plus I sine pi on 6 all to the power 7. So this is 2 to the 7 cos 7 pi on 6 plus I sine 7 pi on 6, and that's by de Moivre's theorem. So I might reference the fact that I've used that. And now I want to put this in Cartesian form, in exact Cartesian form. So let's see if we can evaluate cos 7 pi on 6. Well, that's something that lives in the third quadrant, so we know that actually both sine and cos are going to be negative. Now, what is cos pi on 6? If it was in the first quadrant, it would be pi on 6. That's cos 30, which is root 3 on 2. But since it's in the third quadrant, I know it's going to be negative. And then it's going to be I times minus a half, because sine pi on 6 is equal to a half, but it's in the third quadrant, so it's negative. So now I'll multiply everything by 2 to the power 7. So I get minus 2 to the power 6 times root 3. But 2 to the power 6 is 64. So this should be negative 64 root 3 minus 64i. And that's the end of part E. Now for the final part of question 11, part F. We want to sketch the region defined by the modulus of z being strictly less than 3 and 0 being less than or equal to the argument of z minus I less than or equal to pi on 2. Okay, so let's start drawing this up. We're going to need an Argand diagram. We want the modulus of z less than 3. Now, the modulus of z equal to 3 is going to be a circle. But if it's less than 3, that means we're not including the circle, but we want everything within it. So I'm going to need to use a dotted line to draw my circle. So I have the modulus of z less than 3 is everything inside this circle, but I also need the arg of z minus I to be between 0 and pi on 2. Now, what's the arg of z minus I? Well, I have to go to the point z equal to I, which is here. I have an open circle, and then I want to include these lines. So this is the arg of z minus I equal to 0, and this here is the arg of z minus I equal to pi on 2. So I'll label this as I. This is, I'll actually label this as 1. The reason for that is because I'm going to label this as the imaginary part of z and the real part of z. Okay, now I want to be in between an arg of 0 and pi on 2. So that means I want everything here. But I also want to be within the circle. So I want actually this part. So I'm going to shade that in green. And for a question like this, I'm going to be very, very specific and explicit. I do not want to include this point here because there's one part of the conditions where it's not included. And likewise, I don't want to include the point where z is equal to 3i. So I'm going to put an open circle very explicitly at those points because they are not included. And that should be my locus, and that's the end of question 11.